So hi everyone, welcome back to the Civrays InMoov, where you can follow along with my progress at building an InMoov robot. Now that we've got the power distributed around the robot, I want to get the forearms reattached. You can see here I've got the forearm ready to go. This is the one we were working on in the last video, with now the wrist working again and the springs installed. And I've also got my laptop here with my robot lab ready to go. So let's get into it. I've designed these little 3D printed brackets to hold my custom made circuit board. So before we attach the arm, I'll need to get this new bracket installed. I've offset the circuit board because we've got the potentiometer down in here and I just wanted to clear that. Just leave a little bit more room on the right. So this is just going to replace the standard InMoov bracket that sits in there. And I'm hoping that I can just prise these bicep parts apart and get that board out of there without actually breaking anything, and then pop this new bracket back in. So I did just manage to squeeze it in there. It was quite a tight fit, but it has gone in. This circuit board just pushes in here. I haven't designed in any screws to attach it, so I will at some point just apply a little bit of glue on it to hold it in. The only thing that's really sticking out a little bit further than I wanted is this header. I was intending to install the board up here. It actually looks like you've got a lot more room up here, but you have to remember that the bicep raises up into this area. So I did design new upper bicep sections with slots in to take a similar kind of arrangement as this, but it didn't work out, it didn't fit, so I abandoned that. And I think this is where the Nervo board is designed to go, so I've gone back to this idea of mounting it down here. The only thing I don't like is this wire sticking out. I was hoping that we'd eventually have some covers over the back here and everything would be hidden, but there will be a bit of a bulge here where this wire is sticking out. We might be able to do something a little different in the future. So I think the next thing to do is to bring the power cables that we provided in the last video down into the arm. Now they will eventually go through the shoulder, but just for now I'm just going to string them over the top. I'm also probably just going to leave them a little bit long, just because we can always shorten them, but we can't make them longer again. So I'll get them connected into here. So they're in there now. They provide power to this servo in the bicep that drives the elbow, and they also come out the bottom here and feed down into the hand. So the next thing we want to do just before we reattach the arm is get this potentiometer in the correct position. So we just want to make sure that this gear here is in the fully anti-clockwise position. So that's fully anti-clockwise there. To attach the arm back on, I'm going to be using these M8 bolts. The shorter one is 25mm and the longer one is 65mm. I'm going to be using ordinary M8 nuts. I'm not using nylock nuts. I might switch to nylock nuts once I'm happy that I won't be taking it off again. But I'm just going to stick with normal nuts in case I want to remove it. I mean, obviously you can remove a nylock nut, it's just a little easier with an ordinary nut. And then I've got these nice black plastic dome caps that will fit over the end of the cap head screws, and they'll also fit over the nut at the other end. Should just give it a slightly more professional look. So if we bring the forearm in, and we just want to make sure the forearm is sort of in the most open position down here, nice and straight, and then we just want a very small gap in this part here. So small gap here, gear fully anti-clockwise. And I can run the bolt through. So the bolt is slightly too short. We probably could have done with a 70mm bolt. Pop the nut on. Don't want to over tighten it because we don't want to make the joint too stiff. And I've got these little black caps we'll put on. Actually, I'm not going to fit the caps because I'm a little nervous that they're a little bit too tight in there where the forearm joins on. They might make the elbow joint a little stiff. So I'll leave those off for now. Just bring in these two power wires from the forearm up to our board. I can actually remove that board, make it a little easier for myself. Just making sure that I get the positive and negative around the right way. We can bring our ribbon cable from the forearm into here. It's actually a little bit long because I said I designed the board to go up here. Now I'm mounting it down here. These cables could be shortened a little bit. I'll try to pop that back in. And then the last thing we need is a ribbon cable from here over to this board here. I believe I've got this from when we stripped him down. So that can go in there. And again, this will eventually go through the shoulder, but for now we'll just take it over the top. And I may have to just double check. I don't remember if we use the top one or the bottom one. And then the last thing we need to do is just bring the forearm up so that these holes line up, and we'll just run a bolt through here. Again, I'm not going to fit these plastic caps. I think they might make things a little too tight. Now I will just show you, because I like to show you any problems that we do run into. And we do have a crack developing here. Now that's been cracked a very long time, over a year probably. And it hasn't totally broken yet. But the only solution for that is to reprint this section of the forearm. And as it's glued to the next piece, we'll probably have to rebuild this whole cover here. Now I'm not actually going to do it until it finally breaks, because I'll probably build a new one and that'll probably break as well. Now when I got to this stage and was ready to power on, I experienced a few problems. I was getting quite a bit of erratic behaviour from the servos, and in particular the shoulder was just acting weird. I actually spent then quite a few days just trying to experiment and diagnose what was wrong. And in the end I did conclude that there were a few different issues. One issue was somehow, I think I deliberately did it, I'd swapped the two Arduinos over. So the original one that we had previously used was now on this side of the robot, and the new one in this position didn't have the MRL-COM sketch running on it. So there were no signals being outputted to the servos, so they're probably just receiving no signal, just randomly doing stuff. The other thing I noticed, that when I compared the backs of these two boards, the newer one didn't have the grounds tied together, and I'll talk about that in a little bit. The last issue I discovered was actually a little bit with My Robot Lab. I'm finding that sometimes it will just stop outputting to the servos and everything will just do nothing. And when it was doing that, I thought my servos were burnt out and just weren't working, but as it turns out, a quick reset of My Robot Lab and it comes back to life. I did discover when I was testing, I was using some little SG90 servos to just test one servo to just make sure things were working, and I found that they did not like the 6 volts. Up at the top end of the range, around 180 degrees, they really started to jitter and a couple of them burnt out. And I found that if I lowered the voltage to 5.5 volts, they seemed to behave a bit better. Now that was just the SG90s. Now I'm not actually using any of those. I only use those in the eyes, and we haven't got the head on the robot at the moment. So that was a little bit of a red herring that distracted me for a little bit, but I did in the end conclude that everything does still work, although I have had some issues with the shoulder. I don't think the potentiometer is reading correctly in the rotate, and the omoplate moving outwards, it does work, but when it comes back down it's catching on the torso. The torso's not quite straight and it's catching on it on the way back down, so I'm not going to operate that. We'll have to come back and try and improve that, but it's going to be a difficult one because it really needs me to sort out the torso, which involves taking everything off again, which I don't really want to do. I'll just briefly talk to you about the issue I had with the ground on the Arduino power supplies, and then we'll move on to some coding. When I originally designed these boards, I designed them with 2 power supplies because I thought I might want to use 2 different voltages, one to feed the servos and one to feed the Arduino itself. But I've since decided that I'm going to power the Arduino via USB. So when I built this board, I didn't connect up the Arduino's power supply. You can see these connections here don't go anywhere. We've only got this one connected up to the servos. Now, even though we're not using this one and we're not powering the Arduino from it, the problem we've got now is that our grounds are not tied together. So the supply for the Arduino, the USB supply, and the supply for the servos here are not connected together via their grounds. It's really important to tie all your grounds together so that everything has got the same reference 0 voltage. So everything is relative to that. So what I'm going to have to do is at least connect the ground up from the Arduino's ground, which I think is second pin on this row, I think. Yeah, it's there. So the second pin on this row needs to be connected to the ground for the servo supply, so that way we've got the grounds tied together. So I think what I'm going to do, even though I'm not using it, I'm going to connect up this board as it was originally designed and connect the supply from here up to the V in and this one up to the ground, and then I'm going to tie my 2 grounds together. So you can see what I've done. The purple wire is the V in, it's just running up to the V in on the Arduino, and I've got a brown wire coming from this connection going up to the ground on the Arduino. And then we've got our all-important link, so we're tying the 2 grounds together. Now, even though we're not using this supply, the point is the grounds are linked together, so it was coming from the servo ground, linking through and going up to the Arduino's ground, so all grounds are connected. So let's take a look at some code. So I've got my Robot Lab here, and I'm just going to open a couple of sketches. The first sketch I've got is called init.py. And you can see here I've got right at the top my COM port. It's COM11 for me. I imagine for you it would be something different. I'm just starting an Arduino service, and then I'm starting a whole bunch of servo services, and then finally I'm connecting the Arduino to the COM port. So if we run this, we'll see a whole load of services open across the tabs at the top. You can see all the fingers and things. So then if I open up the other file, which is called gestures2.py, and you can see here I'm just grabbing all of those services that we just set up. And then I'm creating a couple of functions here, just defining a couple of functions to close the fingers and open the fingers. Next, I'm attaching all the servos. This defines their default positions, their starting positions, and their speed. Then you can see I'm doing a routine here where I'm raising and closing the hand. So we have closed fingers, wrist.move to 0, bicep.move to 60, and shoulder.move to 45. So that will just raise and close the hand. And then we've got this all important time.sleep, which just is giving us a 3-second delay here, and that's just to let all of that stuff happen before we start moving on to other things. And then I've got lower and open, which lowers the hand and opens the hand. So you can see I've got open fingers. Then I've got wrist.move to 180, bicep.move to 0, and shoulder.move to 0. And then again, that all important time.sleep, just to give it time to do all of its stuff. Then I'm just repeating the raise and close again. That's exactly the same as before. Next, I've got this spin wrist. This is just moving the wrist to 180, waiting a bit, and then moving the wrist to 0 and waiting a bit, just to add a little bit more interest. And then finally I'm lowering and opening the hand. It's exactly the same code as we saw before. That just puts everything back into its default positions. And then finally I'm just detaching all the servos to stop them from buzzing. Okay, so pretty happy with that in the end. Did have a few issues along the way, not 100% happy with the shoulder, but generally the bicep and hand and wrist seem to be working. They're not perfect, but they are working to a certain degree. I'm quite happy we got a nice demo. We'll deal with the other forearm in the next video. That should be quite interesting because we should have both arms working at once, so we should have an even better demo next time. One last thing to mention, just taking a look at the reading here for the main batteries, they're now showing 11.8 volts, and I think when we originally started, I think when I first connected up the power circuits, it was reading something like 12.4 or 12.5, so it is dropping, and it's dropping quite a bit. But I've been operating this robot now for about, I don't know, probably a week or more, but obviously it's not on all the time. But I think I've had quite a bit of operation out of it, so I'm reasonably happy that the batteries are lasting. We obviously haven't got the whole robot set up yet, so it will draw more current once we add more servos, get the other arm operating and the head and the stomach. Probably see it drop a bit quicker, but I'm reasonably happy with it. It's probably a little bit too early to say as yet if the batteries are big enough. If you liked the video, please give it a thumbs up. And as always, if you haven't done so already, please subscribe to the channel. Thanks for watching, and we'll see you next time.